Welcome to a platform overview of the wireless mesh networking technologies currently offered by Silicon Labs. In this video, we will provide a summary of the wireless microcontroller units, MCUs, which are currently offered by Silicon Labs. We will also describe the platforms which are supported by these MCUs. Next, we will give a brief description of the different protocols which are supported by our wireless mesh networking products, and present a quick overview of our complete and ready-to-use reference designs, which are now available from our IoT Solutions team. Silicon Labs offers a variety of MCUs for all of your wireless mesh networking applications. The EM35X series is our industry-leading family of wireless MCUs, featuring our most cost-effective solution, the EM357. This family of chips is based upon the ARM Cortex-M3 core, running at up to 24 MHz. They offer up to 192 kilobytes of flash and 12 kilobytes of RAM. For security, this series utilizes a 128-bit encryption accelerator. 24 configurable GPIOs and 2 serial ports are also available for connectivity. The next family of MCUs is our EM358X line. This series increases the capabilities of the EM35X series by increasing storage up to 512 kilobytes of flash and memory up to 64 kilobytes of RAM. If USB functionality is required, this is an option within this series of parts. For added convenience, the EM358X series is pin compatible with the EM35X series, should you want to upgrade to these capabilities in your older EM35X designs. The EM359X series of MCUs was designed for applications where greater communications and I/O are required. This series expands upon the features of the EM358X series, increasing GPIOs to 32 and doubling serial ports to 4. The EFR32 is the newest flagship in our family of wireless mesh networking MCUs. The EFR32 boasts a high-performance ARM Cortex-M4 core running at up to 40 MHz and includes 256 kilobytes of flash and 32 kilobytes of RAM. The new Crypto Advanced Encryption Accelerator supports encryption up to 256-bit in various modes of operation. 28 GPIOs, 2 serial UARTs, and USB functionality are also standard. There is an option for a built-in power amplifier with this chip as well. All of this comes in a new highly configurable package that allows for customizable peripheral locations. With all of these features, the EFR32 is the world's most energy-friendly radio system on chip. At the identical transmission and receive power levels, the EFR32 has lower current consumption than all of the EM35X and 35XX lines. And the peripheral reflex system allows advanced peripheral usage in deep sleep mode, further assisting in reduced power consumption. The EFR32 radio family revolutionizes the low and medium data rate radio market with a combination of unmatched performance and ultra-low power consumption in both active and sleep modes. The EFR32 radio family revolutionizes the low and medium data rate market with a combination of unmatched performance and ultra-low power consumption in both active and sleep modes. This table offers a comparison of the various Silicon Labs MCUs. It starts with our low-cost EM35X series of chips, the additional storage and memory of the EM358X family, the added communications capabilities of the EM359X family, and finally our new flagship, the EFR32. All of these parts can operate in one of two platform modes, which I will go into next. Silicon Labs offers two different platform modes for use with our MCUs, System on Chip, or SoC, and Network Coprocessor, or NCP. In the system-on-chip configuration, the Silicon Labs MCU operates as a single-chip solution for customer application needs. Customers build their application to run alongside our protocol stack. Utilizing the application framework hooks into the protocol stack, the user application drives both external devices while directing the protocol stack to operate the underlying RF transceiver for mesh networking. The result is a compact, unified firmware design that runs from a single memory and storage code space. The trade-off is that all resources, flash, RAM, and peripherals, are shared between the stack and the application. However, this unified approach offers a highly integrated system with minimal external components and a reduction in overall design complexity and BOM costs. The Network Coprocessor NCP configuration is a two-chip solution in which the wireless networking and user application are separated on different hosts. All radio functionality is self-contained in the Silicon Labs MCU operated in NCP mode, while the user application resides in the host device of a customer's choosing. This host can be anything from an 8-bit MCU to a full Linux system. Using the Ember ZNet serial protocol, a serial abstraction of our stack libraries, the host sends commands to and receives data from the NCP, which performs all mesh networking operations. Because of this configuration, BOM cost may increase from a similar SoC solution. However, the benefit is added flexibility to the user design, such as the ability to add mesh networking to an existing system in a fairly easy and modular way, or the ability to upgrade or replace one side of the design with minimal impact on the other. Silicon Labs supports Zigbee and Thread as part of our wireless mesh networking technologies. Zigbee is an open global wireless standard which provides the foundation for the Internet of Things by enabling simple and smart objects to work together with a focus on home automation and smart energy applications. With a seat on the board of the Zigbee Alliance, Silicon Labs is active in the continued development of the Zigbee standard. Silicon Labs offers the Ember ZNet stack and application framework as their complete solution for developing applications with their wireless MCUs and development tools. Thread expands upon the foundations of Zigbee by adding connectivity between the Internet of Things and the Internet, with a focus on low power, security, routing, and native IP support. As a founding member of the Thread group, Silicon Labs is helping to shape the standard of which Thread is built upon. The Silicon Labs Thread stack works with our existing MCUs and development tools to help customers build their Thread products and reach the market as quickly as possible. The IoT solutions team at Silicon Labs has worked to reduce the complexity of Zigbee mesh networking designs and minimize power consumption by providing complete, optimized, and easy-to-use reference designs for Zigbee home automation and lighting applications based upon the Zigbee Home Automation 1.2 profile. These reference designs demonstrate the ease of use of Silicon Labs wireless mesh networking tools and products. They can be a great launch point for customers that are looking to just get started with wireless mesh networking, while existing customers can use the design as building blocks for more advanced applications. The information in this video and more can be found on our website. Visit scilabs.com and search for Wireless Selector Guide, or follow the URL shown on the screen. Additional information and help can be found in our active online community at community.scilabs.com. Thank you.